Okay, good evening. This is Professor David J. De Los Reyes. My topic for tonight will be still advanced mathematics. I think it's now lesson number 37. Okay, don't be bored. The advanced mathematics topics is almost done. Okay, I am just finishing the advanced mathematics lesson. I think the next thing after this will be the Taylor series. Okay, my topic for tonight will be example application problem on the so-called Newton's method of approximation in advanced mathematics. Okay, I will check my camera. Okay, so we are now on lesson number 37, that is advanced mathematics, lesson number 37, Newton's method application problem. So I will now be giving you example problem on the application of Newton's method of approximation in the computation in mathematics, okay? I will try to bring out my calculator, scientific calculator, because later on I will be presenting some calculations. Okay, let's proceed. Lesson number 37. To give you a problem, I will read the problem. Using Newton's method of approximation, find the cube root of 20 to 4 decimal places. The problem is asking for the cube root of 20 equal to using Newton's method. Okay. Actually, we can take the what you call this cube root of this by using our calculator. Okay, let's try to check the cube root of 20 before we will bring out the Newton's method of solution for taking the cube root of 20. So we will place 20 over here. Okay. Y to the x. 1/3 is actually 0.333. So the power will be 0.333. And this should be equal to. The answer is up to 4 decimal places, 2.7144. The answer here is 2.7144. That's the cube root of 20 by using the calculator. So actually, if we try to compare this calculator solution with our final answer, okay, they're the same. Okay, let's try to bring out the solution by using Newton's method of approximation. To bring out the solution, we will let x, there should be a representation, the cube root of 20. Changing how the equation will be written without the radical sign, x is actually equal to 20 raised to 1/3. Meaning the cube root of 20 is actually 20 raised to 1/3. Okay? Then take or raise both sides of the equation to the third power. Okay? X raised to the third power will be x cubed. And 20 raised to the 1/3, raise that again to the third power. We will be using laws of exponent over here. So it becomes 20. 1/3 times 3 is actually to the first, right? Or just simply 20. So meaning 20 raised to the 1/3, raise that again to the third power will just be simply 20. Okay? That's laws of exponents. Okay? Transposing this 20 here on the left, x cubed minus 20 should be equal to 0. Meaning, the unknown value of x, if we raise that to the third power, and we will subtract that by 20, what will come out should be equal to 0. So, another representation now, function of x will be x cubed minus 20. Okay? That's our function of x as related to the given problem. Taking the first derivative, f prime of x, this falls under the power formula. 3x squared minus 0, or f prime of x will just be simply 3x squared. We represented function of x. We have computed for f prime of x. We needed this two here because in the next trial value we need this two. Okay, under Newton's law. So for trial number 1, we let x1 to be equal to 2.5. Oh, this is an intelligent guess. Because if we put x to be 3 over here, okay, 3 to the third power will be 27, okay, minus 20, so actually 27 minus 20, there's a difference 7, so meaning, if x equal to 3, it is actually greater than the required value. So, as an intelligent guess, we will place x1 to be equal to 2.5. You could assume any trial value you want, okay? You can start low or you start very near the correct answer, okay? Function of x1 now. Let's try to check if 2.5 is correct. Function of x1 we'll use this one here. 2.5 cubed minus 20. What comes out? If we try to simplify this one, this is negative 0.4375, negative. There's a negative sign over here. Meaning, if we place x1 to be 2.5, after the subtraction using function of x, what comes out is negative 0.4375. Okay? It's negative, meaning the assumed initial trial value is actually smaller. So I place it here, smaller. Meaning the assumed value 2.5 is smaller than the required correct value. So I place it here, smaller. Let's try to compute for f prime of x1. It's a must that we will compute for this because on the next trial value, we need this one. F prime of x1 will be 3 times 2.5 squared. What comes out will be 18.75. Okay, let's go to trial number 2. That is trial number 1. That's trial number 1. So for trial number 2, under Newton's method, this will be the equation. Right? That is, the next trial value will be the initial trial value minus fx1 over f prime of x1. We computed this one separately, and so with this one, we are given x1. So the next trial value, which is nearer the correct value supposed to be, will be 2.5 minus open quantity. Function of x1 is negative 4.375 over 18.75. A minus over a plus will be a minus, and a minus times a minus, it will be a plus. So whatever the ratio of this one, we will add to 2.5. So supposed to be the next trial value will increase. Because from the initial value, we know that it is smaller. So supposed to be the next trial value will become bigger, right? So what comes out for x2 if we try to simplify this one? Of course, you use your calculator. You should familiarize yourself with using your calculator. Okay? What comes out is 2.733. And if we try to check this one, if this is not the correct value, we place that on the given function of x. Function of x2 now, meaning what will be the given function if we try to substitute this one? So function of x2 will be equal to 2.733 to the third power minus 20. What comes out is 2.733 y to the x to the third power equals to minus 20. What comes out is 0.421. it is 0.421, positive. It is almost zero, but it's not yet zero. So meaning this 2.733 is slightly higher than the correct answer. So I place it here, this 2.733 was bigger. So whether we like it or not, to compute for the correct value of x, we'll go to trial number 3. Okay, if we go to trial number 3, we'll compute for f prime of x2. It will be 3 times 2.733 square. What comes out is 22.412. So for trial number 3, again, by using the Newton's method, this will be the equation. Right? That is x3, the next trial value, which is nearer the correct solution, should be x2 minus function of x2 over f prime of x2. We know this one already, and so with this one. So x3 now will be 2.733 minus open quantity. Function of x2 is actually 0.421. It is plus. Okay? And f prime of x2 is actually 22.412. It is also a plus. So a plus and a plus will still be a plus. But this is preceded by minus. So whatever the ratio of this one, we will subtract that from 2.733. It should not be added. It should be subtracted because a plus and a plus is a plus. And a minus multiplied by a plus will be minus. So the ratio of this one, we subtract that from 2.733. And after the simplification, what comes out is 2.7145. Okay? Okay, let's try to check if this value 2.7145 is now the correct value of x. And how do we verify that one? You just substitute this one to function of x. Okay? So this will be 2.7145 raised to the third power minus 20. 2.7145. Hold on. 2.7145 y to the x 3 equals minus 20. What comes out is 0.00182. 0.00182. It is this. It is not yet zero, but it is almost zero. Okay? It is still a plus. So meaning this 2.7145 is slightly higher than the correct value. So I place it here, it was bigger. This 2.7145 was slightly higher than the correct value because there is a difference of 0.00182. So whether we like or not, we will go to trial number 4. And I think this will be the last one. We could get the correct value of x now. So we'll compute for f prime of x3. For f prime of x3 will be 3 times 2.7145 quantity square. We are using this. Okay, simplifying, what comes out is 22.145. So for trial number 4, and I think this will be the last trial before we could get the correct answer. Trial number 4. Again, by using the formula for Newton's method, x4. Okay, so you notice the subscript. This is 3, this is 3, this is 3, and this should be 4. Meaning, the trial value number 4 should be trial value number 3 minus function of x3 over f prime of x3. We now know this one, and so with this. So substituting, x3 is 2.7145 minus open quantity. Function of x3 is almost 0, 0.00182. Right? It is plus. And the value of f prime of x3 is 22.105. It is also a plus. So a plus over a plus will be a plus, but this is preceded by minus. So the overall sign of the ratio here will be minus. So whatever the ratio here, we will subtract that from 2.7145. And what comes out is 2.7144. Okay, you should familiarize yourself by using your calculator. 0.00182, okay, divided by 22.105 equals, okay, The sign should be negative, so we will place a negative sign. We add that to this, plus 2.7145 equals, okay, what comes out up to the 4 decimal places is 2.7144. Okay, you got it? So the simplification of this by using the calculator up to 4 significant places, 2.7144. Okay, let's try to check if this value now is the correct final value for x. So function of x for now will be 2.7144 to the third power minus 20. And actually, it is almost 20 minus 20. So 20 minus 20 will be 0. Since this is 0, this is the correct value. The correct value for x is 2.7144. So the final value for x now will be 2.7144. We could verify this one, 2.7144. Okay, y to the x, the power will be 3 equals, it is almost 19.9996106, or that is approximately 20. So 20 minus 20 will be 0. Since this is 0, the unknown value for x without any error will be 2.7144. That's it. Okay? Exactly as it is. Because if we try to raise this to the third power, we subtract that by 20, what comes out will be the difference is 0. So this is the correct answer. So the final answer will be, after the fourth trial, will be 2.7144. There will be a question, how come we go to up to the fourth trial? We are showing a solution, right? We will stop when the difference is 0. So because when the difference is 0, meaning to say the correct value at that trial is the correct one. Okay? I think we will not go beyond the 5 trials or 6 trials. Even on the, what you call this, what's this? On the second trial, if you want this to be your answer, it could be, but there's a little difference of 0.421. What we need is that the difference should be 0. And for the fourth trial, the difference is actually 0. So we could say that the final answer is x equal to 2.7144. Okay, that's Newton's method of approximation. Okay, don't be bored, guys. If you will become an engineer, this is how we compute numbers in engineering. Like in civil engineering, in the design of the so-called timber design, there are lots of computations using your calculator. Even in electrical engineering. So just don't concentrate on the so-called SAT. SAT exam is just a part of going to college, right? That's just a part of becoming an engineer. Because without passing that SAT, you will not become an engineer. But as soon as you become an engineer, our calculations will be something like this. So don't be bored, okay? So for those of you who are taking up advanced mathematics, this is for you guys. If you want to share or subscribe to my channel is at youtube.com/@ProfDavidJ. And if you want to share it, please click share. Our topic for tonight is actually an application problem of the Newton's method of approximation. Okay? Good evening from Los Angeles.